Hi guys. I am doing the math for um, section 2, which is Newton's second law. The formula that goes with Newton's second law is this one: acceleration equals force over mass. And really, they're just talking about the relationship between acceleration, about how acceleration works versus force and mass. Like, how much force do you have to put if it's a big mass, or like that. So that's what I'm going to talk about. Either one of these formulas can be used, and I switch between both of them depending on which one I'm looking for. Sometimes it's easier for me to always use this one versus this one because this one's already got division in it. And so I'm going to go back and forth just to show you, but you can pick one and just use one. It doesn't matter, however you want to do it. But let's go over the units really quickly. When we're doing acceleration, we're still going to use the acceleration unit, which is meters per second squared. Okay, force, the unit for force is newtons. And then the unit for mass here is always going to be kilograms. Okay, now sometimes they might give us grams, but we have to convert. So I'm going to use both of these formulas. Each one is fine, whichever one you want to use, but these are the units you're going to use. The majority of the time, it depends on what the problem is. Now, if you don't have your book ready, you need to pause the video and go to page 367. I'm doing the 4 problems on the right side of the screen, and they are page 367, and it's in your book. So I'm going to go ahead and start. If you need to, pause it. A boy pushes forward a cart of groceries with a mass of 40 kilograms. What is the acceleration of the cart if the net force on the cart is 60 newtons? Okay, so I am going to go ahead and use, this one right here. So I'm going to do force, mass, and acceleration. Okay, so my force is 60 newtons. My mass is 40 kilograms, and I'm looking for acceleration. So I can use either of these, any of them. So I'm going to go ahead and use the acceleration one right here. So I'm going to say acceleration equals, and my mass is 60 newtons, and my mass is 40 kilograms, and 60, I have to do it in 60 divided by 40 is 1.5, and then it would be newtons per kilogram, but a newton per kilogram is actually just a 1.5 meters per second squared. They're the same thing because a kilogram times divided by a newton is equal to a meters per second squared. Because if you have newtons per kilogram over here, it's equal to a meters per squared. So that's number 1, okay? All right, number 2, it says, what is the upward acceleration of a helicopter with a mass of 5,000 kilograms if the force is at 10,000 newtons, acts on its upward direction, acts on it in an upward direction? So I am looking for acceleration. So I'm going to go ahead and just use this one right here. Acceleration equals force over mass. I'm looking for acceleration, so that's going to be there. My force is 10,000 newtons. My mass is 5,000 kilograms. So that would be what? 20? No. You'd think I know this, but let's just pretend that I'm just doing it for y'all. 2. Okay, so 2 meters per second squared. Don't tell anyone I just did that. Okay, so that would be 2 meters per second squared. That's number 2. Pretty simple, right? Okay. Number 3. An automobile with a mass of 1,200 kilograms accelerates at a rate of 3 meters per second squared in the forward direction. What is the net force acting on the automobile? Okay, so I need to know what the net force. And it says, hint, solve the acceleration formula for force. So what they're saying is that you would use this and solve for force, but why not just use this? Okay, So this one, I am going to use this one. And I mean, I could do it either way. Either way works. Do it however you're comfortable. I like this formula better, to tell you the truth, but whatever. So I'm looking for force, because that's what I'm solving for. And my mass is 1,200 kilograms. And my acceleration is 3 meters per second squared. He's saving us from danger. I think the mailman's out there. Oh, gosh. Or a chihuahua. Okay. So it's 1,200 times 3, which would be 3,600 kilograms times meters per second squared is equal to a Newton. So that's my unit. Force. Newton. All right. And then the last one is 4. A 27 Newton force accelerates a boy. I can't read today. Okay, a 25 Newton force accelerates a boy in a wheelchair at 0.5 meters per second squared. What is the mass of the boy and the wheelchair? Okay, so this one says solve for, hint, solve Newton's second law for mass. I still wouldn't do it that way. I would do it this way. Okay, so you can do it however, but I'm going to put 25 newtons here. I'm looking for mass, and my acceleration is 0.5 meters per second squared. Okay, so I'm going to divide this and divide this, because whatever you do on one side, you got to do to another. And so these would cancel out. My mass is equal to, so 0.5 is 50. 50 kilograms. All right, so that's my answer. So I'm going to have you do a worksheet tonight or today, and I'm going to have just certain problems, because it's a worksheet that I took from a different book, and I don't want you to do all the problems. I just want you to do some of them. So I hope this helps you guys. If you have any trouble, refer back to this, but I think you'll be okay. Okay, bye y'all.